Greatest common factor, right? And so we look at that and say, can we do a GCF, right? Let's start there. Oh, crap. No GCF. Okay. Well, where do we head from there, right? The one we used a lot was AC method, but the AC method only works if there's 3 terms and sometimes 2 terms. So we can't use that here. We had difference of squares, but that was only for 2 terms. That's not going to work. Sums and differences of cubes. I mean, these aren't cubes, and there's not, and those are only, again, 2 terms. And, right, Kyla, grouping. The grouping was for 4 terms only, right? Because we had to break it down the middle. So none of our tools work, right? Everything we know about factoring isn't going to work here to help us factor this. So we got to come at this from a different angle, okay? And so that's what today is going to be, is this different angle. This is going to come out of nowhere. It's not going to make any sense as we're doing it, okay, the first time, but we'll get there. Okay? It's not going to look like anything that you've ever done before. So just open your mind, right, is what I'm trying to get at here, is that we're going to do something called synthetic division, and yeah, I mean, it's just going to look bonkers, okay? So, but it's actually really easy. So, but it's going to start off looking really weird, okay? So this is that problem that we just looked at, right? X to the 4th minus x cubed minus 21x squared, okay? It's the same problem right there at the bottom, right? One that we got yesterday that we made. And notice that we are dividing it by x minus 5, right, which is right here. Okay, so I'm taking this and I'm dividing it by this. Okay, that's what this problem up here says to do. So divide using synthetic division. So let's get that going. Make sure you write that down correctly. And I'm going to write out the steps on the side here. The problem is the steps are actually really easy, but they're a pain in the butt to write. So there's a lot more words that I have to write in order to describe what we're doing, but what we're doing is super simple, okay? So step 1 is what I call check for gaps or look for gaps. The gaps thing is kind of my terminology. So just be aware of that when you're looking for gaps. Okay? Basically what that means when to look for gaps is to look at the powers. Okay? They want to see if there's anything that's missing. So this one goes 4, 3, 2, 1, and then there's no x's here, right? So 4, 3, 2, 1, 0. So this problem has no gaps in it. Okay, we're just looking to see if there's something missing. There's no like set highest number. There's no, okay. So it's just checking to see what's after that. Okay, so real quickly, if I look at the next problem, 4, 3, 2, 0. So this problem has a gap. Notice how there's no just plain old x term. Okay, so that's what I mean by a gap. This one has a gap at the x term. This problem does not have any gaps, but you always need to look. It's just kind of like looking for a GCF. Always start there. After that, we are going to draw a half box. So as you draw your half box, I knew that was going to happen. Let's group this up here. So your half box needs to be 2 or 3 lines tall on your paper. So 2 or 3 spaces on your paper, okay, tall, and then just as long as the problem is. Okay, so 2 or 3 lines vertically, and then however long the problem is. That's your half box. Step 3, you're going to put the coefficients of the dividend, which is the thing that we are dividing. What is being divided is called the dividend. This is your dividend. Put the coefficients of the dividend at the top of the box. Okay. So put the coefficients of the dividend at the top of the box. So the coefficients of the dividend. So those are the numbers in front of the variables. Okay. Go away. So I have a 1 there in front of my x to the fourth. I have a negative 1 x cubed. I have a negative 21 x squared. I have a positive 1x, and then my constant term here. So those are my coefficients of my dividend. So again, 1, negative 1, negative 21, 1, and 20. So do not bring down the x's. Okay? Make sure your signs, those minus signs, are important. Okay? Step 4. I'm going to put the 0 of the divisor. So the divisor is the thing you are dividing by. So that is my divisor. On the left. So the 0 of my divisor, I set the divisor equal to 0. You guys have done this. Solve that. That is the 0. X equals 5 is the 0. So I put a 5 over there. For pretty much all you guys are going to do when you do synthetic division, it's just a sign switch, guys. Okay? .99% of the time that we do this in this class, all you will have to do at that step is just switch the sign as you bring it over. Not a big deal. There. So that is the setup, right? That was a lot of writing to really not do much stuff. Okay, so it looks really complex, but that's how you set up this problem. Okay. If you make any errors in the setup, you're screwed. Right? I mean, there's no way to do the problem correctly if you don't set up the problem correctly. Okay, so you've got to stop and just go back at this point and say, did I write down all the numbers across the top right? Did I check for gaps? Okay, this by far is the #1 mistake people make. Okay, is not finding gaps, not identifying that there's a gap in the problem. Okay, the next most common mistake is that sign switch. Okay, how easy is it to forget to switch that to a positive 5? Super easy to forget that, okay? But it changes everything. Okay. Step 5 is how we actually start this. Okay. So you just bring that first number straight down below the line. So that 1 just drops straight down. Okay, don't do anything to it. Now this next part, I'm going to do it in a really kind of messy way, just so you guys can see how the numbers move, and I'm never going to do this again. Okay. So basically what we're going to do from here on out is we're going to do the same 2 things over and over again until we run out of numbers. Okay. We're going to multiply and then add. We're going to multiply then add. We're going to multiply then add until we're out of numbers. Okay. So we're going to take that 5. And we're going to multiply it to the 1, and that's going to go up and to the right. So 5 times 1 is 5, and then we're going to add straight down. -1 plus 5 is 4. And we're going to keep doing that until we're out of numbers. Okay? So I go back to the 5. Times the 4. 5 times 4 is 20. And then I add straight down. That gives me -1. Start over. 5 times -1 is -5. add straight down. It's -4. Last one, 5 times -4, it's -20. Add straight down, we get 0. Okay. Once you guys get good at this, it takes you like half a minute at most to do one of these. Right? They're really fast. The setup is easy. You're doing multiplication and addition, which should be things that you should be pretty good at doing in your head. Okay. Of course, if you're worried, then you need to be typing it out. But and of course, it's easy to make little mistakes, but it's also easy to fix them. So, okay. But you got to get the problem set up right, and then the rest is just quick multiplications and additions, and just kind of being careful with yourself there, right? Not rushing too much to get through it. Okay. So what does this get us, right? How do we move forward with this? It's got a bunch of numbers here. What do I do with them? Okay. So I want you to pay attention to these 4 numbers right here. 1, 4, -1, and -4. All right? 1, 4, -1, -4. I'm going to go back to the last page. Oops. So we just took this and divided this out of it, right? Remember what division means is like, what do I, if I say what's 100 divided by 5, another way of saying that is 5 times what is 100, right? So if I say what's this divided by this, another way to say that is x minus 5 times what is this? Well, we know x minus 5 times this gave us that, right? And what were those 4 numbers? 1, 4, -1, and -4. 1, 4, -1, and -4. There are those 4 numbers. 1, 4, -1, and -4. Well, what's here that we don't have? All these x's. So remember, one of our first steps was to take the x's out. Remember, we broke the coefficients down. It took all the x's out of the problem. So our last step is to put them back in. Okay? So that's how this goes back into being x's. We got to put the x's back in. So there's a, yeah, like that. So real quick, when we do division, like what's 75 divided by 7, right? I say, okay, well, 10 times 7 is 70, and then I know that 5. What's that 5 called? What's that? Then we get that 5 down there at the bottom that we can't do anything with. What's it called? Yeah, Mason, it's the remainder, right? So that last number, the very last thing we get when we do division is always the remainder. Okay? This is the remainder. We got a remainder of 0, right? What does it mean to get a remainder of 0? Well, if I had taken 70 and tried to put it into 84, well, 7 and 84, 7 goes into 8 once, is 1, and 7 goes into 14 twice, right? So we get a remainder of 0, right? What's special about getting a remainder of 0? Well, 7 is not a factor of 75, but 7 is a factor of 84. So this here tells us that this x minus 5 was a factor of this, which better not be surprising because remember we got this thing by multiplying x minus 5 to something, okay? So we're seeing that this is a factor of this thing, okay? Alien. So that's all that means, all right? This is something we'll explore later, okay? But there's the remainder, okay? What did that -4 represent? Okay? The -4 is just a -4. Numbers without variables are called constants. What did that -1 represent? The -1 represented the x term. What did that +4 represent? It represented the x squared term and that positive 1 represented the x cubed term. So the way I like to do this is I always know that my very last number, that very right number, is the remainder. Always next to the remainder is the constant term, right? No variable. Next to that would be an x term. Bigger than that would be an x squared term. Bigger than that would be an x cubed term. So I like to build from the right to the left because I always know that the rightmost number is my remainder. And then I can make it bigger from there as I move to the right. So how I interpret those numbers, I see 1x cubed. Oops. I see positive 4x squareds. I see negative 1x, so just negative x. And then I see negative 4, which is just, again, a constant, no variable. So this is called my quotient, right? The answer to a division problem is the quotient. So when I divide all that by x minus 5, here's what I get. Which again, we should have already known because we knew that yesterday that this times that was this. But, so always what I'm trying to do is show you that this works. Right? This is kind of a proof of concept. We see that we multiplied those two things yesterday, we got this thing, and now we're dividing it out, so we better get one of the things we multiplied by yesterday. Okay? So we see that. So it had a remainder of 0, so there's nothing at the very end. The next one we're gonna see is what happens if that's not 0. Okay, so this should be kind of like in your mind right now. Well, that's fine. That's what it's supposed to be. We're gonna do another one. Is there anything right now though you want me to clarify on this guy? It's just like not making sense. Where did something come from? Why did I do this? What happened here? Ask the questions you guys got, man. This is the time. How you doing, Kellen? I know you said you looked crazy earlier. Yeah. Yeah. Let's do another one. Since only people speaking up are saying they are good. All right, here's the next problem. Make sure you write that down correctly. Normally we do long division and then we do synthetic division. And, long division with polynomials is pretty much like long division with numbers, like you just saw me do. 75 divided by 7. It's just more complex, but the thoughts are all the same. And then we say, well, hey, we can do this long division, and oh my God, it's horrible. But like, oh, we can do this. It's called synthetic division, and it looks really weird, right? Like super weird looking problems, but look how fast it was. Like, and everybody's like super excited. And we end up using synthetic division to help us do a bunch of other stuff later. So this really is kind of like a tool right now that you guys are sharpening. Okay, to kind of like with factoring, like we need to know how to factor in order to do a whole bunch of other stuff. So knowing how to do synthetic division is going to make other things possible for us. Okay, so this is really just a skill right now you guys need to hone. Okay. So remember, number one mistake people make when doing these problems, okay, gaps. Is something missing? Okay, are there gaps? There's not always gaps, but if there are, you've got to address them. And the idea is you look at the exponents, 4, 3, 2, then it drops straight down to 0. Okay, that's not okay. So what I want to do here is I want to fill that gap. Basically, we need a placeholder. We need 0 x's there. Okay, and you could put plus 0x or you could put minus 0x, but usually it's just easier to put plus. Okay, so we need a placeholder. That's all it is, just a placeholder. All right, but you have to put 0 x's because if you put 1x in there, you're changing the problem, and that's not okay. But we can put 0 x's in and not actually change the problem. It's just a placeholder. So that's the number one mistake people make with these types of problems, is not identifying gaps. Then we draw our half box. Okay. Across the top of the half box, we need our coefficients. So that gives me 1, 2, -7, 0, negative 14. Okay? That 0 absolutely has to be there in order to do this right. Second most common mistake people make, right? Switching the sign. So as we look at that, x plus 2, right? The 0 for that, right? And the real math behind that is x plus 2 equals 0. So that means x equals negative 2. That's why we switch the sign. But oftentimes it's easier to remember that I need to switch the sign. Okay? So there's math behind it. It's not just like, well, let's just do it because. Okay? We're dividing out the 0. Okay? And then the third most common mistake I've seen over the years that I've taught this is that drop that first number. Okay? That comes just straight down below the line. Okay? Nothing happens to it. Either I've seen students like put it here, or they multiply it by negative 2 as they bring it down. Okay? It just needs to come straight down. Okay? And once we have it set up, what do we do over and over? Multiply and then multiply then add. All right. So negative 2 times 1, that goes here. So negative 2 times 1 is negative 2. Then I add down, which will give me 0. Let me start over. Negative 2 times 0, of course, is 0. So there's going to be a 0 up here. And I add down, gives me negative 7. Negative 2 times negative 7 is positive 14. That goes here. So always go up and to the right. Positive 14. Then you add down. Oops, that's not 0. It's 14. And then negative 2 times 14 is negative 28. We add down, we get negative 42. Okay? So yeah, we can, once we have to stop writing all that stuff, even there, sitting us talking through that, it maybe took us a minute to do that. But really, these will be very fast for you guys. Okay? Now you got to stop and slow down and say, now how do I interpret my answers? Right? I got all these numbers. What do I do with them? How do I get my answer back out of it? So this is where I think it'd be a good idea for you guys to label these things. Okay? I'm not writing my answer right now. I'm just labeling things. So that last number, that rightmost number, is always the remainder. Okay, so I just call it an R. And then next to the remainder is the constant. Okay, I see it. Sometimes I'll see students jump straight to putting an X there. Remember, you're supposed to just have a plain old number right there. Then the X, then the X squared, then the X cubed. And if I had more numbers, if I had a longer problem, then I would have an X to the fourth, and then I would have an X to the fifth. There's nothing about like us doing these problems that says they have to have X cubes to start with. Okay, it's just purely about the size of the problem I give you. So this one started off with an X to the fourth. It's dividing out an X, so it better end up as an X cubed. So that's the only thing that it is. This was an X to the fourth divided by an X, so it's an X cubed. Okay, that's the only thing that tells you how big this should be. There's nothing else determining that. So I don't want you guys getting locked in saying, hey, it has to be an X cubed at the front. It does not. Okay? It's just about how many things there are in the problem. And once you've got things labeled, then you can go back and write your quotient. So X cubed, I have 0x squared, so I'm not going to write that. Minus 7x's, it's a positive 14, so plus 14. Now, how do we write a remainder? Okay, so our remainders get written as fractions of the divisor. The divisor was x plus 2. So you write the remainder as a fraction of the divisor. So the negative 42 became minus 42. So if that had been a positive 42, that would be a plus sign. So just following the sign there. Over whatever you were dividing by, right? Not the negative 2, okay? We were dividing by this. So this is what we were dividing by. So the remainders get written as fractions of the divisor. Okay, so that's what this is. This is a fraction of the divisor. If we go back to that, 70 into 75 problem I had earlier, it was 10, which is 70 over 25. So when I take 75 divided by 7, I get 10 and 5 sevenths. That's what it means. All right, we say that 5 over 7. Right, it'll be 5 sevenths. Okay, so we have, this is our remainder, so we have it over the divisor. Okay. You guys want to try one more? We'll be done. Let me look real quick. Let's do this one. Wait. Yeah. Oh well. So we got 2x cubed plus x squared minus 8x plus 5, all divided by x plus 3. So the first thing I want to do is look for gaps. 3, 2, 1, 0. No gaps, so we're good to go there. I'm going to write my half box. Bring down my coefficients. So 2, 1, -8, and 5. There are my coefficients. Second most common mistake, sign switch. So it says plus 3, so we're going to write minus 3. Check, got my sign switch. Third most common mistake, right, drop that first number. Straight down. So this time we're bringing a 2 down. And then we multiply, add, multiply, add, multiply, add until we're done. So -3 times 2 is -6. 1 plus -6 is -5. -3 times -5 is 15. -8 plus 15 is 7. -3 times 7 is -21. 5 minus 21 is -16. And you're done. Okay? Probably did that one twice as fast as we did the last one. So that's all the math, and then the rest is interpreting. R, C, X, X squared. So see how I'm topping out an X squared now? That's just how big the problem is. So 2x squared minus 5x's plus 7. I need some fraction of the divisor, right? X plus 3 is what I'm dividing by. I have 16. There's a -16, so I'm going to write minus 16. So fraction of the divisor. There's our quotient. Okay. Again, this is a skill you guys should be honing. Okay, we're going to be using this to do some other stuff. Okay. Anything here you guys want to talk about? I think I gave you guys like 5 problems I want you guys to try. See how they're going for you. We'll come back and talk about like how they did tomorrow and add another little layer of things on. But